You have an idea of how to visualize your data in a plot. Please avoid Chartjunk. To get an idea of what Chartjunk is, we have this quote from Edward Tufte. The interior decoration of graphics generates a lot of ink that does not tell the viewer anything new. The purpose of decoration varies: to make the graphic appear more scientific and precise, to enliven the display, to give the designer an opportunity to exercise artistic skills. Regardless of its cause, it is all non-data ink or redundant data ink, and it is often chart junk. A very obvious example for this are often grid lines or figure frames, or the way the lines in plots are labeled, and we'll go over these examples in a bit. It is critical that you carefully assess the purpose of the ink that you're using. When you make a figure and something is displayed on it, you should be in charge and say, yes, this is here because I want to convey this piece of information, and not this is here because that's the way the software does it. Let's go over some examples here. Moiré art. This moiré vibration, probably the most common form of graphical clutter, is inevitably bad art and bad data graphics. The noise clouds the flow of information, as these examples from technical and scientific publications illustrate. What moiré vibrations are is that you have rapid changes between high contrasting colors, and when you look at them, they move in front of your eyes. You can kind of see them vibrate a little bit. This graph is jam-packed with all of this, and none of that conveys any information. There's no need to have these checkerboard bar graphs over here. They could be a solid color, or they could just be lines. Similarly over here, there's no need other than somebody wanted to do something fancy and show off all the cool patterns that they can make. What it does is it totally distracts from the information. And even though in this circle, everything is differently patterned, you still have no ability to tell apart how much of this donut belongs to which piece of the data that have been collected. Another example is here a mix of moiré art and Necker effect. The moiré art here is, again, these lines that kind of create this vibration of the image if you look at it. What the Necker effect is that you look at a 3D object, which is shown here with the coordinate system, but you cannot quite tell whether you're looking inside of it. So, is the outside of the cube taken away, and this is kind of an inside corner here, or you're looking at it from some kind of underside where this corner is actually an outside corner of the object, and then it has on the underside these strange triangles or pyramids on it, which in my mind results in a constant shifting back and forth between looking inside and then seeing the outside. When I look at this, I do not see any need for a third dimension. There isn't any labeling here. There's no explanation for why the data are stacked this way. If there were, you could probably just show them in a bunch of line plots instead of this unnecessarily three-dimensional plot. This shows my pet peeve, which is grid lines and how they obscure the story the data are telling. What we're seeing here is population of France by age and sex in January 1st, 1967. We have half of these data that is male, another half that is female. On the outside vertical axis, we have year of birth. On the inside, we have the age. What you can see is that you have few members of the older population, and that increases as people get younger and reaches some constant down here at the bottom. But there are some interesting features in here, and they are labeled. For A here, you have military losses in World War I. And if you look closely, which you didn't probably see right away, is that in that population, you have fewer males than females. It's asymmetric. For B here, around 1916, plus minus a few years, you have a huge decrease in population of that age, which is due to a deficit in births during World War I. Kind of extending across this is C, which is military losses in World War II. And then D, there's another deficit for births during World War II. And then E shows the rise of births due to demobilization after World War II. What Tufte has done is taken the same data and removed all of what he considered junk. And if you look at this visualization, these key features jump out at you without even having to annotate them. You see very quickly that there's an asymmetry in the older age group between male and female. You also see very quickly that there are two periods where birth rates were decreased substantially. And now, if you want to inquire further, you either can add some sparse labeling here to indicate what these things are, or you just let people count. Here you say what the horizontal grid lining is and what the vertical grid lining is, and then they can figure it out by themselves, or you add it to the text. What has happened here is that there's a lot less junk around the actual data, which tell you the story and which tell the story now a lot clearer and easier to grasp for the reader. What we can see here is another example of overuse of grid lines. We have small multiples. So repetition of kind of small area plots that all contain data. But in this visualization, the data is totally overwhelmed by the effects that the small frames of these small multiples create. What happens here at the intersection is that there's a disproportionately larger white space that is being created, which creates these white dots that draw the attention away from the actual data. The frames are also black, the same color as the data, and there's a lot more ink being spilled to create the small multiple frames, the outside frames, than on the actual data. Tufte's version of that reduces the heaviness of the frames by changing their color to a lighter gray, and then brings the frames together so that they have joined vertical and horizontal axes. If you wanted to, again, you could add some labels to your axes, but perhaps the data are telling the story already by themselves. That is a decision that you have to make as the creator of the figure, whether you can write a story around this that conveys the information, or whether you need to add some additional information. The bottom line for this remains that now the data stand out, and the gray frame provides some support in which to understand these data, rather than drawing all of the attention away from the story that you want to tell. This example is what Tufte calls a duck, which is a big fat thing that uses a lot of ink for something that doesn't convey any information. What this figure shows is the partitioning in age for college enrollment between 1972 to 1976. They draw a distinction between students that are under 25, which is up here, and 25 and over, which is up here. If you look at this graph carefully, you will easily see that in 1973, where we had 29.2% of college students that were 25 and over, and we add 70.8% of students that are under 25, we get 100%. In fact, we get 100% every year, because all you do is you take 100% of your students and you check which percentage is under 25 and which percent is over 25. So these curves, as you can see visually, mirror each other. You do not need a complex graph like this to convey that information. There is no need to add a third dimension other than showing off your three-dimensional drawing skills. There is no need to connect these lines in these fancy waves, because these are discrete measurements taken at each year. The way these graphs are drawn actually suggests that there is a midterm enrollment change that gradually changes the composition between under 25 and over 25 students from here 28% for 25 and over to 29.2%. But that is wrong because these data are measured discretely for each year, so that they shouldn't be connected. And you do not need those two graphs. You can stack that information into one of them, or perhaps much better, just put it in a table where you have 5 years and your respective measurements that add up to 100. You can have a table that is very small that conveys that information much better than this complex graph. So when you're designing your figure, you should think about the effectiveness of visual elements. Here is a ranking of some visual elements by effectiveness, starting at the top here from most effective to least effective. I think we can all agree that position on some kind of scale is very effective to convey information. Similarly, the length of line segments and directions. Angles get perhaps a little bit more complicated. Area in 2D is okay, but it's starting to get more complicated to really intercompare the differences between these areas. It gets more complex with volumes, and then luminance and shading and color saturation become much less effective. You have to contemplate how you can convey the information in a simplistic and effective way. Think about color contrasts. Here, there's a simultaneous contrast shown where we have a color gradient from white to black in the background, and then gray rectangles plotted on top of it. The color of the gray rectangles is the same, and you can see that there's one in the middle that you can't even see because it is the exact same color as the background. That same color looks a lot lighter in front of a black background and a lot darker in front of a whiter background. Yet, if you had a color bar below, you would never assume that these might be the same color and assign the same value to them. This is similar for color contrasts. Here we have the square with the stars are of same color. But here the square is surrounded by more squares of the same and lighter color, so it appears darker than this square, which is surrounded by more squares of a darker color, so it appears lighter. If you were to try to connect the color value to some numerical value on this scale, this would end up with a lower value than this. You would try to put this perhaps in the 20 to 30 range, and this might be perhaps in the 0 to 10 or 5 to 10 range. So as you're designing your figures, pay attention to what elements you use, how clear they are in the communication of the story that you want to tell.